Please start the webinar countdown timer now. Greetings to all. I am Daisy, and I will be the webinar moderator. Welcome to the 12th Masterclass Series webinar of the OMSE Learning Academy. Today's webinar topic is hydrocarbon management and reconciliation. We have an overwhelming response from many countries, and we welcome you all, and hope you all will have a very informational and interactive session today. Before we start, let me discuss a few house rules. The webinar will be 40 to 45 minutes long with a 10-minute Q&A session. You can enter your question in the chat box during the presentation, which will be answered at the end. The webinar will be recorded and available on the OMSE Learning Academy website. There will be a 2-question poll at the end for your input. Please give us your candid feedback at the end via the redirected Google form. Today's speaker is Dr. Suresh Agrawal, the founder and CEO of Offsite Management Systems LLC, and Academy Director of OMSE Learning Academy. I welcome Dr. Agrawal to speak at this educational free webinar. About our speaker's organizations, Offsite Management Systems LLC was founded in 1998 in Houston, Texas. It's chartered to provide consulting and refinery automation project executions worldwide. OMSE Learning Academy was founded in 2018 to provide continuing education to professionals working in the downstream refining industry and related businesses via the e-learning platform. This webinar will teach you 3 concepts related to the hydrocarbon management and reconciliation. First, we will discuss the concept of hydrocarbon management, also known as mass reconciliation or oil loss in a refinery, to set all definitions up front. Second, economics of oil loss as to what does it mean to a refinery in terms of loss of profitability. Last but not least, the focus of this webinar will be technology and methodology to estimate and minimize the oil loss to an industry average of 0.30 to 0.50%. Thank you all for attending this informative webinar. To appreciate your efforts, we have 2 complimentary gifts for you. Please stay until the end to learn about them. With this, let me request today's speaker, Dr. Agrawal, to start the webinar. I will be back at the end of the presentation. Thank you.
Good morning or good evening. I'm Dr. Suresh Agrawal, and welcome to this 12th webinar in the series. So today's topic of hydrocarbon management and reconciliation. We'll talk about definition of terms. I'll define various terms that are used in the industry, like hydrocarbon management, mass reconciliation, or oil loss. Then we'll discuss the areas of losses in a typical refinery and how to estimate them, how much profitability is suffered because of these losses and not be able to account them properly. Then we take some case studies and what are the best industry practices and some software which are used in the marketplace to help to manage the reconciliation of oil loss. And what is the next technological advances in the last 2-3 years? We'll discuss those. So what is loss and gain in refinery? If you look at the refinery picture here, refinery gets a receipt and it sends out the products to the customers. And in between, it uses some of the products for its own use, and some are lost. Some of them losses can be accountable and unaccountable. Unaccountable means there cannot be measured, estimated, say almost lost forever, but they are making an effect on the balance. So we'll talk about all this terminology in detail in the seminar. So hydrocarbon management is also referred, as I said before, mass reconciliation, mass balance, yield accounting, or oil loss. These all mean the same thing. And sometimes people say one thing, but another thing, but they all mean that how to manage the hydrocarbon management in a refinery. So mass reconciliation is a process which is mostly carried out at month end. It's rarely done on a daily basis. But I was involved in a few refinery projects where a refinery tried to do this at daily balances. and they put every system in place, all the department interaction, other things, and it was so intense that after a month they gave up and went back to monthly end raises. So this is a typical way of doing it at the end of the month. They close the balances and they have enough time during the month. And as a result of that balance at the end of the month, it generates a final refinery loss, percentage loss or gain, which is again mostly termed as oil loss. We all know the refineries assets are in the tanks, liquid assets, and they are worth billions of dollars, not millions, billions of dollars stored at any point. So it's like a stagnant money lost, opportunity lost. And all those assets, if they are not accounted properly, that it means the loss of profitability. And it undertakes millions of dollars in transaction. They get the refinery gets the products in and out. They get the shipment, crude shipment, and they sell the products out. So not only the assets are stored in the tanks, but the transaction is also taking place in refinery in terms of millions of dollars. So it requires very accurate accounting of daily liquid assets, how much in the tank, what is coming in, and what is going out, because that's what the refinery profitability stays. So on the top of it, it requires that the refinery optimize their units production from the crude oil to different products. Per plant strategy and reconciliation is essential part of a determining production loss. And last but not least, it's very important to accurately calculate estimated percent loss and gain. It could be due to flares, slopes, emission leakage, etc., to balance final financial ledger. There are some terms which we use in this webinar, and they are used sometimes interchangeably with different systems. Like for TIS, it's also called TIMS, which is a tank inventory system. Oil movement or order movement management systems, SAP or global SAP systems, which is basically accounting for financial accounting. And then oil accounting systems also used in the industry, which is a book of records, they call it sometimes, which makes a ledger of open and closed inventory, what is booked at the fence line orders and what is shipped out. And then the data reconciliation, data rec. The terminology may be different, but I just want to make it a point that these are different kind of a system used for different purposes. And then material balance, which is sometimes you can use a system like Sigma Fine if you're not using a refinery, and something from Invensys or Schneider. So these are the typically 6-7 systems are used for balancing hydrocarbon or oil loss, calculating the oil loss. So what is on use and losses in refinery? In terms of on use, fuel gases, fuel oil, FCC coke, and waste gas from H2 plant. These are the ones that refinery uses within its operations. Now, accountable losses are chemical loss, fugitive loss, and flare loss. Now, when I say accountable losses, the impression I may be giving, they're 100% estimated, calculated. Yes, but there are still some calculation errors and measurement errors. So, but that's something that refineries can really account for. Now comes on what unaccountable losses. These are handling losses, which could be error due to not starting the pump in time, not measuring the tank inventory. Then again, meter uncertainty. If meters are not properly calibrated, then it records the losses, error losses, faulty errors. It's not true. And leakage water and slope. Slope is something that refinery sends to either waste or recovers the product. Say, for example, if you're blending and blending is out of spec and it doesn't make any sense to recorrect it because that's a loss of product. So sometimes they send it to slope or some other means or recycle in a crude tank. In a typical plant, there are three areas. Fence line, at the inlet and fence line at the outlet. From the inlet is the products, receipts are coming in by different means, tankers, pipeline, trucks, and rail wagons. And outside is again, products are going out again by tankers, pipelines, trucks, and rail wagons. In between, these products are moved in the tank inventory in the tank form from one tank to another to blending tanks to make the products. And the fence line balancing is done in ERP, which is custody transfer. It means what you're receiving from the vendor and what you're shipping out the customers. There's a custody transfer protocol in place. And then we have a unit balancing, which is how much is produced in the units, and are the meters are calibrated? Are they reading correctly? So how do we do the unit balancing will come down the road in these slides. So these are the areas which are important from a refinery mass balancing point of view and has to be calculated, measured, estimated, whatever means to come to a close figure. And sometimes they are successful, sometimes they are not. And you will see what I meant. So in a typical process of flow measurement to the financial control, so we start with the hydrocarbon management landscape where all the parameters are measured, all the flows are measured, and then you go to mass balancing, which is reconciliation in and out, losses and other factors come into picture. The yield accounting, you go to yield accounting, how much is loss from different sources, and it goes to loss control, which is typically a KPI for the finance part, and then recycle back to the measurement again, which is corrected. Any error in the meters, any error in the tank gauging systems, and other things, any error in coming, recording the shipment and the receipts. So we have ATG, automatic tank gauging system, and flow meters, and custody transfer meter. The custody transfer meter are also very critical to be calibrated properly because that is what the customer will record it, that what is received, and that is what you will record what you receive from the vendor. And this is all managed through various subsystems and control systems. So what is essential of a hydrocarbon management landscape? So you're getting a shipment receipt and you're passing through the tank form through oil movement and tank information system, and then you're going to the process units and then to the shipment. Now, then in between, when you at the tank form, you're doing the assets balancing because that's where you want to measure what's in the tank accurately, as accurate as possible, because you have a tank of 100,000 to 300,000 barrels capacity from crude oil product tanks. And even 0.01% error in the measurement can cost in terms of billions of dollars. Then you have a baseline balancing, unit balancing. So these all have to play together in a very organized and collaborative ways in the refineries, not only the control system, but also different personnel and staff. So let's look at the refinery fence line balancing. Just to reiterate that I cannot say that which area is more important. Every area in the hydrocarbon management is important. Whether it's a fence line, whether it's a oil movement, whether it's a unit balancing, all the area contribute toward that final goal of minimum oil loss. So fence line balance reconciliation is really not about finding the difference between import and export. In part it is, but not quite. It's more of a closing gap, what was booked for receipt and shipment versus actual. Now, you may be surprised, but I was told by the actual refinery finance manager, I asked the question that how much really the loss? He said, well, you'll be surprised. Sometimes we have lost about $100,000 in the bookings. Either it was ship out short or it was received short. And where the balance comes, then it's all about balancing that, what comes in, what comes out. You can think of like a checkbook, what get deposited and what get expensed out. It has to be balanced out. Fence like reconciliation is did by ERP system like a SAP, GSAP, all about finding any missing booked and or executed movement orders for financial controls. and it's important piece of for overall refinery reconciliation. Let's look at the unit balancing. What does really unit balancing means? So you have a process units and you have it produces the streams for further processing, and you have a meters which is labeled as F1, F2, F3, F4, and then it sends to the tank T1, T2, and then from there it feeds again to another process units. Now, through mass reconciliation, the meter F2 flow meters and the level of T1 should reconcile. Whatever is sent to the tank T1 and T2, the change in level should match with the flow. Now, that's where the meter reconciliation comes into picture, or the calibration. Now, we'll discuss that how this affects the actual profitability of the refinery. Let's look at this. A refinery planner makes a plan from the particular type of crude and sets a target for set point for each of these streams. He doesn't care at that point whether the meters are calibrated or not, because that comes from a linear programming point of view. He sets a target. Now the targets are downloaded to the controller, which is FCSS1, FSS2, and FSS4. And the controller is supposed to set the point to the target points, and the flow meter measures the flow is going out. Now, what happens if the meters are not calibrated? So the set point controller is sent certain target to the controller, and flow meter is not reading what it's supposed to. So the controller will keep on thinking, well, the flow meters are calibrated, so what I'm reading back is what I've set. But doesn't happen. That's where the problem of flow meter reconciliation comes into picture. And and how do we know that? When you measure the level changes in the tanks and compare what flow meter has read, you'll find the error, and that's where the reconciliation comes into picture. So after this, after facts, the mass reconciliation comes picture. So the yield accountant or financial controller looks at all these parameters and try to make a balance that what the process unit sent to the tank and what tank says received are they balancing. If they're not balancing, then there's something wrong in somewhere. Either the tank are not measured properly or the flow meters are not working correctly. Give you example of refinery balance. So we are processing input in millions of tons. The crude received process feedstocks, which can be other component than the tank, than the crude. Then blending feedstocks, blending additives. We also importing some slope and fuels, imported gas, and then we calculate the opening stocks and closing stocks, and say total process input is say 8.77. Now on the outside side, we are measuring the dispatches, how much is sent to the customer, feed to the chemicals, other products, and we go down the line, fuel oil, fuel gases, FCC4, and then we come with the balance of 866.5. Now this is a very ideal situation, but so our loss is 8.711 minus 8.665, which is 0.046 million tons. Now, how much this translates into loss, we'll see. Now, in terms of accounted loss, we have a flare, drainage, evaporation, fugitive, down the line. I mean, there are many. If you look at it, the flare and drainage evaporation the highest, at 26%, 19%. This is where the loss is distributed. But good news is refineries do calculate these things. There are systems and methods and instruments to measure the flare and drainage evaporation. So we go down the line. Now, then unaccounted losses are also 16,148, about 35%. So 65% is accounted loss and 35% unaccounted loss, which we cannot account it, but it's lost. So if we take all these things, we have lost 0.046 and total input was 8.711. So this is 0.53. It's called the oil loss. Now, typically in the industry average is between 0.3 to 0.5. Now, if your refinery loss falls in that range, I mean, you are doing great. But variably, to reach that range, there's a lot of discipline involved, a lot of instrumentation involved, a lot of procedure involved in there. And and I'll show you if you don't have that, what happens. So uh, just to reiterate again, credit and debits in hydrocarbon landscape. You have a credit, you have a debit, and you go down the line, open inventory, shipment, consumptions, production. Some are manual, some are automated, and refining loss becomes credit minus debit, just like a balancing a checkbook. The overall picture, you can see the complexity and calculation of at every step. Now, each of the steps could involve total automation or partly automation, partly manual, and a lot of communication from one department to another department. I have worked with refineries for this oil loss systems, and it's a mind-boggling that what is involved in this thing. And this is not just 1 or 2% job. Sometimes I've seen 100 people working on making sure the calculation are correct, making sure the measurements are correct. And it's a really stressful job. I've seen it, and I know for refinery professionals working. But this is a total map how the hydrocarbon management is managed in a refinery. Now, if you take it a blending system, simple blending system, um, it starts with a tank, it goes to the tank. In between, you have a receipt, shipment, consumptions, on use, loss and gain, and it makes a balance. Sometimes all are lumped together, but nevertheless, this is a little bit more accurate calculation because depends the error in the tank management systems or the AGT, you still come out reasonable loss in the blending system because of the tank level changes. So in terms of process of mass reconciliation, is a lot of steps involved in there in terms of capturing the data, in terms of finding the errors in the data and integrating data together. So it goes raw data from oil movement and from tank information system. It captures it, then it lists the inventory changes, it calculates it, and then it produces the complex calculations. Now, we all know that it's not the inventory, that's not enough measuring the level. It's also the temperature is important and that's important for to calculate the actual inventory because the volume changes with the temperature, and there are procedures involved. So it's a complex calculation, and the movement from one tank to another, and how all the professionals are coordinating with all this work of field equipment and management of tanks. So this is a example of a typical system from a vendor where you look at the tank balances and it can immediately point out the error where the tank balance is not correct. Now, tank balance is not correct because of the input flow error or the AGT system is not working for that particular tank. But it points out that this is a significant imbalance in a particular tank or pair of tanks. So the softwares are very sophisticated nowadays from 4 or 5 vendors, and we'll see in the end. So I took 3 years of oil loss, which published records, and you can see the range varies anywhere between 0.2 to 0.8, and the average deviation is between 0.4 to 0.55, which is a normal distribution of monthly loss. Now, this is a very ideal situation. It's not, at least I have not seen for every refinery. I have worked about 6 or 7 refineries in the last couple of years. And surprising thing is that you can see monthly mass balance. Now, what do you see here? You see the bar above the line and below the line. Now, what does below the line means? It means that's a loss. It's a negative. But above the line, that means it's a gain. And if you know physics, mass can never be gained. Only you can gain volume, but not the mass. So where this discrepancy is coming from is all in the measurement, the errors. Take a different view, then you can see it's a refineries calculations and methods and measurements gives error. It indicates this a gain in the mass, which is they know it and we all know it. It's error. What is true is only the loss, which is negative scale. So this happens. And when this happens, then refine looks at it. How come our calculation showing the gain in mass? It should be only the gain in volume. So if you take economics for a oil loss, and this is I took a 8 refineries published data from Shell. I had done a project with Shell, and I said, well, the oil loss is about 0.5%. If our system can reduce 10% of that one, which is 0.05% oil loss, 10%. So how much is the gain? And you look at it that you can see that different refineries have a different capacity. And based on that, you can see the potential improvement in reconciliation and estimate tangible benefits. 0.8 million, 1 million, 2 million. If I take all the 7, 8 refinery, it runs into about $40, $50 million per year. Just 10% decrease in the oil loss. So the percentage may seem very small, but the effort to achieve that is huge. I mean, it has to have a disciplined approach by the refinery to meet that lower oil loss. So it's all in the accurate measurements in terms of fence line reconciliation, which require custody transformators, stock inventory, which requires ATG, automatic tank gauging system, and inventory management system, unit reconciliation, which is the meter calibrations, and then oil movement, which is inter-tank transfer from back and forth. And so all these 4 major areas contribute huge oil loss factors in the financial profitability of a refinery just based on the oil loss. So the mantra is to manage, we must control, and to control, we must measure. So if you look at it, tank transfer quantity based on multi-point temperature is uncertain by 0.15%. And, turbine meters, process flow measurement, wave bridge, and ship measurements, and 10% from the fuel estimation. So these are the errors in the estimation of different parameters and different variables. So here is the example. If I have 25 tanks and each has multi-point temperature measuring devices and remainder 16.7% stock is held in 5 tanks using 1-point temperature measurement. So you can see the error about 0.31% because of the temperature is not measured across the tank height and just 1-point measurement. So all these are best industry practices. How should the tank levels and temperature should be measured? And based on that, these estimations are predicted to minimize the oil loss. A typical landscape data flow in refinery is a lot of pieces moving from fence line balancing. How do you enter what is coming in? How do you enter what is going out? How does the book of records enter? And databases and personal. And fortunately, I was involved every system of what you see in the screen. And it's not a small task. And if you're working for refinery, you know for a fact that this is a huge effort and has to be a very disciplined effect if you want to gain that millions of dollars of reduction in oil loss. So in terms of strategic approach to managing a hydrocarbon refinery, the first focus should be the fence line balancing, because this is where the control comes from the vendor and the customer. What you're receiving from the vendor, is it you're receiving what they're saying they're sending, or is the customer receiving what you say is sending? So this is important. Once you achieve that one in terms of fence line balancing, the next comes the bottom line balancing, which is take the fence line balancing and the production consumption, calculate on use, accountable loss and gain, and unaccountable loss and gains. So typically, refineries are recommended to follow two approaches: perfect the first phase and then move to second phase, like a divide and conquer. So we go to different. So what are the refinery doing to adopt to minimize oil loss? That quite a few technological advancement, and one is to have an advanced control system for the process units to minimize the material loss. The shifting decarbonization and shift to low carbon technologies like clean hydrogen, electrification, and carbon capture, utilization storage. The third thing refineries are getting into is integration of renewable feedstocks, not from crude per se, but what are the other renewable feedstocks. And then optimization of existing resources, enhancing what you have in terms of processes, in terms of subsystems, and just make sure that you are using the latest technology which is available now. So how does AI plays a role in minimizing the slope management? Um, it optimizes the slope oil treatment. AI helps in detecting the sensors, process parameters to optimize the treatment of slope oil, whether it's a recycle to the crude tanks or is a done by other methods. Predictive analytics. It generates the quantity and quality of slope oil generated from different processes. Automatic control system and resource allocation. Sometimes the refinery process the slopes inside, I mean in-house, or they send it out to process it and get it back again. And monitoring and compliances, which is very important in terms of how do you process the slope oil. So all these factors are done using AI in last 4 or 5 years since the advent of artificial intelligence, and refinery using slowly but surely all these tools to automate and minimize the oil losses. So going again, how AI use oil loss is a predictive maintenance. It means to know the before the equipment failures. So they can analyze the data from different sensor and operation history. Process optimization, not only for the process units, but also after process unit like blending and other things. Energy management, minimize the cost of energy uses, electricity and fuels and other things. Supply chain and inventory management, like what is coming in and what is going out. This has to be managed properly because that's where the money could be lost if you are not accounted properly. Safety and risk management, and emission monitoring and control. So AI is helping in all these processes to make the refineries profitability better and also minimize oil losses. There are 4 or 5 commercial systems available in the marketplace. Sigma Fine, most of you heard. There is error solver, MAB, master balancing, which is also from a couple of companies, Spintech and Invensys, and the virtual mesa production. I cannot say which one is better, but they all work for the same goal. So in summary, we have discussed an overview of hydrocarbon management. We identify different elements and walk through a typical reconciliation, oil loss, or management of hydrocarbon process. We also talk about the economics of hydrocarbon management, how easy to lose millions of dollars if your management is not proper for reconciliation and oil loss. And then we listed some commercial software. That ends my.
Thank you, Dr. Suresh Agrawal, for a wonderful presentation. We have now concluded our presentation for Webinar 12. Our Academy has offered monthly webinars on fascinating subjects related to downstream refining operations. Refinery optimization, from input analysis to operations configuration, will be the topic of our upcoming webinar, the 13th in the Master Series, which takes place on May 22, 2024. This webinar will discuss how linear programming (LP) models can be used to optimize refinery operations, emphasizing accurate data, strategic planning, and collaboration. They highlight iterative refinement, real-time validation, and case studies on optimizing blends and investments, enhancing decision-making and operational efficiency through meticulous data management and cross-departmental collaboration. Remember to set up an account on LinkedIn. We are beginning registration on LinkedIn on May 1. We will now begin the question and answer session. You can email us any more questions at the email address below and the ones you posted in the conversation. We will ask you to poll multiple choice questions for candid comments following the Q&A session. Would you kindly take a moment to respond multiple choice questions? First, what is your biggest challenge in hydrocarbon management and reconciliation? Second, which area of hydrocarbon reconciliation do you think benefits most from advanced analytics? We will now begin the poll. We will close the poll now. Thanks for participating in the poll. Your answers will give us insight into our webinar content. Our complimentary gift is an ebook with 250 plus pages after you complete the survey. We provide a free 1-hour consultation with our academic director, the webinar presenter, Dr. Suresh Agrawal. Please take advantage of this chance to talk to him about any problems you are having in your refinery, or how to sign up with our academy to receive the benefits of e-learning. We hope to see you at the upcoming webinar. When you exit the webinar, it will lead you to the Google survey form where you may provide us with insightful comments. Thank you, and have an excellent remainder of your day or evening.